Okay, so I'm working on the next 5 questions from practice test 3. This is question 11. The directions say divide and simplify. Looking at the expression that we have x squared minus 4 over x squared plus 4x minus 12 divided by 7x over x plus 6. So we are dividing two rational expressions, or dividing fractions. When we divide fractions, we multiply by the reciprocal. So we're going to rewrite this as multiplication. X squared minus 4 over x squared plus 4x minus 12. If you have trouble remembering what to do, there's a phrase you can use: keep, change, flip. So you're going to keep the first fraction, you're going to change the division to multiplication, and flip the second fraction. So we're doing the reciprocal to get x plus 6 over 7x. Now once you have it changed to multiplication, we want to simplify by factoring everything we can factor and canceling any common factors. So starting off with x squared minus 4, we want to factor that. We always start with greatest common factor. There is no greatest common factor, so then I'm going to count how many terms we have. I've got 2 terms. 2 terms is my indication that I've got one of my special factoring patterns. And this squared is leaning me towards difference of squares. So difference of squares, I'll write it on the side here. A squared minus b squared, this is the pattern I'm looking for. And if I have that pattern, it factors to be a plus b times a minus b. So I have that pattern here, x squared minus 4. We're going to treat 4 as a perfect square, 2 squared. And that factors to be x plus 2 times x minus 2. So then I'm going to move on to the next set of terms, x squared plus 4x minus 12. We're going to factor it, factor the greatest common factor. There is none. We count how many terms we have. We have 3 terms. 1, 2, 3. Terms are separated by plus and minus signs. So we have 3 terms, and because I have a 1 in front of this x squared, this is my simple factoring, my basic factoring. So I'm going to set up my 2 binomials. Okay, 2 binomials. And what goes in the front needs to multiply to be x squared, so that's x and x. What goes in the back needs to multiply to be 12, negative 12. There's a bunch of factors of 12, 1 times 12, 2 times 6, 3 times 4. I'm going to choose 2 times 6. And we need a plus 6 and a minus 2 so that we get that 4x in the middle. So we got 2 numbers that multiplied to be negative 12 and added to be 4. So the second fraction has x plus 6, which is already in factored form, and 7x, which is already in factored form. Once I have everything completely factored, I'm going to look for common factors, and I'll look within the fraction. So we have the x minus 2's within this fraction that cancels. And then after I've looked at each individual fraction, I'm going to look on the diagonals. So on the diagonal, I have x plus 6 here and x plus 6 here that cancels. And that's all that cancels. We're going to multiply straight across with what's left. So in the numerator, I have x plus 2 left. In the denominator, I have 7x left. So we've simplified this division to be x plus 2 over 7x. On this next question, we have simplify, subtract, and simplify. This would be question number 12 on the practice test. We have x squared plus 12x over x minus 4 minus 12x plus 16 over x minus 4. So we are subtracting fractions, and we know when we subtract fractions, we have to have a common denominator. So looking at these two denominators, we have a common denominator. So we are going to be able to combine these fractions into a single fraction. The only thing I need to be careful of is I need this minus sign to apply to all the terms in that second fraction. So we'll write this as x squared plus 12x minus 12x minus 16. And we have some like terms that we can combine. The plus 12x and minus 12x cancel. We have x squared minus 16 over x minus 4. And when we finish our adding or subtracting, we need to make sure that this fraction is in lowest terms or reduced form. So we need to factor. So taking a look at that numerator, x squared minus 16, that's one of our special factoring patterns of the difference of squares. That's going to factor to be x plus 4 times x minus 4. And we can see that we do have a common factor of x minus 4 that cancels. And that's going to leave us with x plus 4. So we've now written that in lowest terms. On this example, we have add and or subtract, then simplify completely. We have r over r plus 8 plus 8. So we are adding fractions. When we add fractions, we have to have a common denominator. So we're going to treat this as 8 over 1. And to get that common denominator, we want the two denominators to match each other. So since this one is a 1, I'm just going to try to match it to the other one. And we're going to have that common denominator become r plus 8. Now when we change the denominator, we're going to multiply by a form of 1. So we're going to multiply by a fraction with r plus 8 over r plus 8. So that will give me r over r plus 8 plus, I'm going to take that 8 and distribute it to both of those terms to get 8r plus 64 over r plus 8. Now we have a common denominator. So we have a common denominator. We can combine the numerators together. That's r plus 8r plus 64. Combining like terms, we have 9r plus 64 over r plus 8. And we'll leave that there. We should try to factor the numerator to see if anything cancels, but I don't have any common factors in my numerator, and definitely none that match the denominator. So this is our answer. So in this question, we have solve the rational equation. I believe this is question 14. Negative 7 over a plus 7 over 4 equals 2 over a. So we have an equation because it has an equal sign, and we're solving the equation. We're going to try to find the value of the variable that makes this equation true. So when we solve equations like this, we have a variable in the denominator, and we need to get rid of those variables in the denominator before we can start our solving techniques. So we need to come up with the least common multiple of all the denominators. So that's going to be a and 4. And if there's nothing in common with those denominators, we can just multiply them together to get the least common multiple. So our least common multiple is 4a. Once you get that least common multiple, you're going to multiply that 4a by every term. So I'm multiplying 4a times the first term, negative 7 over a, 4a times the second term, 7 over 4, equals 4a times 2 over a. And what this is going to do, it will cancel out all of our denominators. So on the first term, we have an a in the numerator and denominator. On the second term, we have a 4 in the numerator and denominator. On the third term, we have a's in the numerator and denominator. So we cancel out all of those fractions. Let's write down what we have left. For the first term, we have 4 times -7, that's -28. For the second term, we have a times 7, that's 7a. And for the third term, we have 4 times 2, which is 8. So looking at what we have left, we have -28 plus 7a equals 8. This is a linear equation. I'm going to solve for a. So I'm going to add 28 to both sides. 7a equals 36. We're going to divide by 7 on both sides, and we have a equals 36 over 7. There's one more thing that we need to do. We need to make sure that this solution works in the original equation. So we need to make sure that we don't divide by 0. So if I were to substitute in the 36 over 7 in these two places, I don't get 0, so I'm able to keep this solution. All right, and here we have question 15, solve the rational equation 9m over m squared minus 25 minus 7 over m minus 5 equals 1 over m plus 5. So when we solve, we want to get a common denominator, but before we get a common denominator, we need to put the denominators in factored form. So this one right here, m squared minus 25, I can factor that more. 9m over, and this is one of our special factoring patterns, the difference of squares, m plus 5 times m minus 5, minus 7 over m minus 5 equals 1 over m plus 5. So when we're looking for that least common multiple of all the denominators, you can see that we have a factor of m plus 5, which is in common. We have a factor of m minus 5, which is in common, and that will cover everything. So our least common multiple is going to be m plus 5 times m minus 5. So once we decide on that least common multiple, we're going to multiply that by every term. So m plus 5 times m minus 5 multiplied by 9m over m plus 5 times m minus 5. Then we take our second term and multiply by that least common multiple, m plus 5 times m minus 5, multiplied by 7 over m minus 5. Let me zoom out a little bit. And then we're going to multiply that least common multiple, m plus 5 times m minus 5 times the last term times 1 over m plus 5. Well, once we multiply by the least common multiple on every term, we should be canceling our denominators. M plus 5 cancels, m minus 5 cancels for the first term. M minus 5 cancels for the second term. M plus 5 cancels for the last term. So what do we have left? We have 9m minus 7 times m plus 5 equals 1 times m minus 5. So let me distribute to get rid of those parentheses. We have 9m minus 7m minus 35. I was careful to distribute not only the 7 but the negative as well. Over here, 1 times m is m, 1 times 5 is 5. And combine like terms, 9m minus 7m is 2m. minus 35 equals m minus 5. So this is a linear equation because m is to the first power. Let's collect the m's on the same side. I'll subtract m. That's m minus 35 equals negative 5. I'm going to add 35 to both sides, and m is equal to 30. So with m equal to 30, there's one last thing we need to do. We need to make sure that if I substitute m into these here, we don't get a 0. So if I substitute 30 in here, I get 30 plus 5, that's 35. 30 into here, 30 minus 5, that's 25. 30 minus 5, that's 25. 30 plus 5, that's 35. So we never divide by 0, so we're able to keep that solution of 30.